Hi, and welcome to Pythian's Expert Insights, a series dedicated to providing expert knowledge on the bleeding edge of technology. Today, we are joined by Pythian's Cassandra team lead and Cassandra MVP, Carlos Rolo, to take a closer look at running Cassandra.
Hello, my name is Carlos Rolo, and I'm here to introduce you how to run Cassandra and install your first server and going from there to a full-blown cluster. A little bit about me. I'm the technical team lead at Cassandra practice in Pythian. I've been working with distributed systems since 2010, and that's been a focus of interest since I started programming at Joint University. I've been working with Cassandra since 2011. It was actually the first year I deployed a live cluster. The live cluster was 0.8. I think I still touched a bit into 0.6. Meanwhile, I became a Cassandra MVP. I also attained the DataStax certification for architect, and I'm also the organizer for the Lisbon meetup for Cassandra users. You can follow me on Twitter with the handle CJRolo, or you can connect to me on LinkedIn. So for this presentation, I'm going to give a brief introduction, talk about the tools you will need. How do you actually set up the operating system for optimal Cassandra usage? Going through the installation of Cassandra, configuring the system after Cassandra is installed to make sure that Cassandra will run smoothly, then configuring Cassandra itself, how to test if everything is fine, how do you add the extra nodes, a bit of summary, and to recap what has been taught today. So, we're going to set up a system for production Cassandra. These are the steps you follow if you actually want to go live. You need to install a set of tools. You need to properly configure your OS. The OS has to be Linux. There is a Windows coming by, but it's not considered stable yet. Then how to install Cassandra and configure Cassandra. How are you going to test installation? How are you going to create the cluster? And adding a node to the data center and finally get the full cluster working. So the first part is about the tools, what you need. Linux installation. You will need Java 8, GRA or JDK, it's up to you. Make sure it's the Oracle Sun Java version. It can run on the open source, but it's actually not recommended, and the Cassandra will warn you if it detects that it's not actually running on the Sun JDK or GRA. Java GNA may be needed. It's depending on the installation you perform. And you also, of course, you'll need Cassandra. You can pick the latest stable version, is a good starting point. And the latest, at the time of this talk, the latest stable is 2.1.11. So, first of all, get your Linux box running. It doesn't matter the flavor, although it's known to work on almost everyone. I'm a fan of the Red Hat and CentOS flavors, but widely working with Debian and Ubuntu boxes. The first thing I always do when I install Cassandra, before I install Cassandra, is I configure the clock. So I install and configure NTP. I make sure that the pool is set. Then I make sure that it is started on boot. So yeah, you do reboot, and then your clocks are no longer in sync. And then make sure that all the clocks are actually in sync. This is mandatory because Cassandra, as a distributed system, is highly dependent on your clocks. Then you need to install and configure Java, go to the Sun website, download the package. You can pick up the RPMs or the depths or even the RGZ, and just make sure that your update alternatives as Java is actually the default Java, not the open source one. You can also install GNA directly. So you download the jar file from the internet and you go to the Java you just installed to the lib directory and you put the jar file there. It should give you the base system for the Linux installation. Then you need to configure some settings on the operating system itself, because Cassandra is really resource intensive. And by default, the Linux systems do not give unlimited resources for whatever program is running. So you need to change the configurations for the user you actually have. I will recommend creating a Cassandra user for a Cassandra installation, and then you go to the limits.conf file. If you create a Cassandra user, you can call it cassandra.conf, for example, and then you just have to set the following settings: so the mem location, the no file, then proc, and IS with the settings it presented. This should allow you to have your operating system not causing problems to your Cassandra environment. Some operating systems need something extra, especially CentOS and Red Hat, even Oracle Linux. They make another file for security reasons called 90nproc.conf, and it's normally stored on this directory. You need to go to that file and increase the number of processes. Otherwise, even if you have the Cassandra user, it can still be blocked by the number of processes. And another thing is you can increase, and you should increase, the memory maps in cctl.conf or equivalent on your distribution, and make this setting to this value. Finally, the firewall. For security reasons, you should not run with the open firewall. If you are on Amazon, don't forget your security settings, otherwise everything will be blocked. And the ports that you need are the following: so 7000, 7001, 7199 for GMX, 9042 for CQL or binary, and 9160 for Thrift. And we are still not ending with the operating system. So what we can do is, we have still the swap. It's an ongoing discussion. It's based on actually personal preference. The documentation says that you can disable and you should disable. I personally don't like to disable swap. I normally set the swapiness really low, for example 10, because I don't like the servers to die on me without any apparent reason. Of course, the swap will keep your server alive, but it also means that the machine that is affected by swap can grind to a halt and can cause huge performance impact on the queries that go to that node. So this is something that you need to be aware. If you have swap, you need to look out if it's not in usage, and if it's in usage, you have to know how to deal with it. Otherwise, just disable it, and when a node dies, a node dies. Cassandra is resilient, and it's made to work with servers going down and going up all the time, as long as you set up the proper configuration replication, so it should not be an issue. Again, it's up to you. I just give my opinion on this. Also, like I said before, create a Cassandra user. It's not mandatory, but it's a good practice to have some degree of isolation. So now we go back to installing Cassandra. You have several choices. You can pick the RPM, the dep, or the targz. If you pick the first two, a lot of the settings I talked before will be automatically set up. It will set up your environment settings. It will create a user for you. I think they even include DNA currently, so you don't need to do a few of the steps that I told before. But if you pick the targz, you need to do it by yourself. So after the installation or done packing, let's assume that we're going with the targz. So there is no automation, and you follow all the steps up to here, and you have full control on your installation. Again, it's a personal choice here. So first thing is make sure that Cassandra has the rights to where to write the logs and to where to write the actual data. So this will be varlib Cassandra in the default settings and varlog Cassandra. Also make sure that if you create the Cassandra user, that these folders are actually using the current permission so that the Cassandra user can write to them. Another point here is these are directories that you can change in configuration, and you have to make sure that these two directories are actually in two different hard drives. because the log is a sequential write, so it's not matter to being written in a slow spinning hard drive, while data it's read and write a lot of time on sometimes unpredictable fashion. So SSDs are the way to go. And you don't want that the log files actually slow down your actually data write and read. So make sure you separate the hard drives of these two directories. Now let's going into the configuration of Cassandra. So always touch these files. The logback is all about your log configurations. The Cassandra recdc.properties is to make sure that you tell where your node lives and what is the configuration of your cluster. In hardware-wise, let's say, it can be in fact about the real setup of your boxes, or it can be the virtual arrangement for your boxes in your payload. Cassandra.yaml is the main Cassandra configuration file, and the Cassandra.sh is the Java settings for the Cassandra. So, logback, like I told you, is all about logging. You have lots of things that you can log on different directories. I'm a fan of var log Cassandra. That's what every log should be. Again, if you have other preferences, other way to manage your logs, just make sure that your logs go where you want them to go, and at least use the info level. So at least everything info or above should be logged. The Cassandra recdc properties. So this file is, like I said, about where your cluster lives. And this file will have the information about in which data center this node is, and inside that data center in which rack it is. Well, the data centers, it's the physical distribution, or you can create virtual data centers. And the racks is just to guarantee that if you set multiple racks, Cassandra will not set replicas of the same data on the same rack. So if actually a full physical rack goes down, you don't lose all the replicas for the same data. So it actually will give you downtime if there was that. So by the rack, it can be actually a physical rack, can be a AWS availability zone, or can be the Azure equivalent. So, or you cannot use the racks at all, but you have at least to give it a name. Then we get to the main configuration file, so Cassandra.yaml. So for package installs, it should install on etc Cassandra conf. For the tarbals, it's wherever you extract /conf. And if you are running the DSC deployments, it will go for etc DSC conf. This file is extensive, has a lot of settings. It's actually really well documented, contrary to some other projects around there. It's really well documented. You should not touch everything, but by reading the comments, you can see that you already know your workload and you already know your environment. You can tweak the settings accordingly to that. And some fields, once changed, they can never change again, or it will be really difficult for you to manage your cluster if you want to change those fields. So these are fields that I always go. I always check what is going on there, even if it's not mandatory. So the first is the cluster name. Normally it's set to something like test cluster. So that gives you a name about your cluster. My first Cassandra cluster, Pythian cluster, my company name cluster, development cluster. So make sure it's the same and make sure it's the same everywhere. Then we go to the directories, like I told before. So make sure that the directories exist, and the directories are in different mount points, at least the data files and the commit logs. And then you have the saved caches directory. You can also change that, can live on the data directory. Then we have the seeds. The seeds needs to be changed, and since we are assuming it's the first time you are installing Cassandra, this is the first node, so just make sure the IP or the name of your node is here. Then the listen address, you put again the IP of your node there, and to incoming client connections, the RPC address, you do the same. You can read the notes about these settings, especially about the listen and the RPC address. For example, listen should never be 000, so you should not be listening on every IP available. And another thing, that it's with the endpoint snitch. This should always be, if this is for a production system, gossip, even if it's not, you should always have in gossip property file snitch. This guarantees that you can move your nodes well, and it's a really easy to maintain snitch. There are also specific snitches like the AWS and EC2, but even so I would recommend the gossip property file snitch because it allows you some flexibility, and the others I don't think bring anything wonderful new that you need to live with it. Then you have some settings that the compaction throughput megabytes per second, it's highly dependent on your write ratio, also highly if you have hardware for it. Concurrent compactors, this I think it's going to be discontinued. If you have disk speed, if you have cores available, you can tweak this one. Also, this is dependent on your machine. It's not impacted the full cluster. You have some additional ways to test these settings without impacting your cluster. We can go to that later. Then you also have the concurrent reads write counters is highly dependent on your hardware. Trinkalif is a setting that should always be true if you are on SSDs, and your saved cache directories. Just make sure it exists. Cross-node timeout. If MVP is enabled, this will gather statistics on your timeouts and will improve your Cassandra clusters. So, like I said, NTP must be enabled. I always have this option true. Then you have one thing that's called the emergency vaults. They can give you a bit of time, but if they on emergencies, and guarantee that your nodes live a bit longer. But if this is your only way out, this means you're going to run into problems no matter what. So most likely you will run out of memory. So you get OAM from the JVM and your node will go down. You have the reduced cache sizes and you have the reduced cache capacity. But again, you can leave those on default. It's pretty safe, the defaults. And if those settings are activated, your log will have information about that. And it should be easily visible that you are eating these settings. So you installed, you configured, you want to test it. So you want to say to people, hey, I have Cassandra running and it's running well. So you start Cassandra. If you have the package installed, should be on your system CTL on the newest operating systems, or on service start on the ones still using the old ways. First thing I always do is I grab for GNA. GNA is essential. So just make sure your GNA, when you grab the log, you will see GNA malloc is successful. And then grab for errors or warnings. And if nothing there, you are good to go. Your cluster is working. One last step for confirmation, run no tool status on your console, and you should see something like this. So it's saying data center DC1, as you configured on your snitch properties, and you see that when means your node is up and it's normal, the IP, how much data, and the token it has, and also the rack it belongs. You want to make really sure that everything is working. So just insert some data. So launch SQLSH with the IP address of your box. You can just follow what is written here. So you create a key space. I always create a key space called sandbox, not only for testing, but also to do some experimentations. On the replication, you can use, I always use network topology, although that you can use the simple. But this allows me to extend, reduce, etc. the key space and actually testing when I add more nodes, more data center, if everything is fine. Then just switch to that key space, create a table, insert some data into it, and then you select the data and you should get this result. This should means that, okay, this node is fine, you can read and write data to it. So now, okay, your node is fine. Let's go adding another node. So you install another node, follow exactly the steps you follow for this one, add the current node you just installed as a seed to the old node. You shouldn't add the two nodes as seeds. Seed nodes won't bootstrap, so we won't pick data from the previous one because it assumes it knows everything. Seed nodes are, like the name said, so they assume they have the data, they know everything. So if you want to change it at seed, you should do it later. And another thing I always do is, of all the settings I told you, I never change the cluster name until I verify that the new node is working. This avoids misconfigured nodes to join the cluster and cause some problems. So once you started, once you see the GNA is running, the directories are there, you can write data. Just delete the data directories, change the cluster name, restart Cassandra, then you have it. Two nodes running, you're good to go. Another thing is we are in the age of automation. Everything is automated, want to do everything really fast. Avoid doing that with Cassandra, adding multiple nodes at the same time. You can even install them and do everything at the same time, but start each node at least with 2 minutes between them. I actually recommend a bit more, it also depends on the data size you have, but too many nodes at the same time will, well, data needs to go to the new nodes, right? So lots of streaming will happen, and if you need to increase your number of nodes fast, pick a time with low usage. And even if you have no usage, always give the 2 minutes. This will allow gossip to settle. So once all is verified, everything is working again, clear the directories, change the cluster name, restart. Never forget to make sure everything is running before adding the cluster. Changing the cluster name, and don't push misconfigured nodes into your cluster. Only thing you need to do if you have additional nodes is you go to the previous defined key space, for example, like defined here, just change the replication factor to 2, or if you don't need, you don't change it. Then you do node tool status, you see that you have a new node, it's up, and you see the J there, which means it's joining. So that's why the 2 minutes. You never add a node before the previous one has joined, so until both nodes are UN. So a summary of everything. So what is needed to have a correct installation of Cassandra, how to configure actually the server, how to actually install and configure correctly Cassandra for production, also how to test and verify your installation, and how do you add extra nodes to the cluster.
Thank you for joining us today and watching Pythian's Expert Insights. Remember to connect with Carlos using the information provided here, and if you want to discover more about our expertise in Cassandra, visit the URL at the bottom of this page or email us at info@pythian.com. Thanks for listening.